Salutations. Today is a beautiful day for science. I'm going back to Angstrom 171. This one is, I think, the most telling on this situation due to the coronal loops that we can see going further out. You can see from the side-on view these far-reaching loops and how they're bending downward and outward. This is because it's post the flare, post the blast, as it were. And there's going to be some swaying involved in that. It's good stuff, but mostly what we're seeing in this is that the interaction in there definitely cascaded something. I'd need to see more images upon images, sort of looking at see the differences and where it goes, so that I can see exactly which loop. Because normally I like to see which loop interacted with which loop, or if a particular loop just, had a problem, or sometimes a filament eruption can cause the entire situation entirely. You'll get the filament eruption before even the flare, and the flare is caused by the filament eruption. So in other words, you get a CME that causes a flare, instead of the other way around, where you typically hear about solar flares that are followed by a coronal mass ejection. But if you look at this beautiful sway that's here on the 171 angstrom, this is due to that essential shock wave from that solar flare, the M-7.34, I believe it was. And this right here is why, look at this beautiful arrangement just to the south of it as well. You got a ton of filaments hanging out and some stray loops. Pardon me, you have, you can see some transfer of plasma from some regions. Just the southern is very, very interactive right now as well, but nothing that's significant to impact Earth, as it were, but as much as just beautiful on the sun. Anyhow, back to the EM class. Sorry, I get sidetracked. Yeah, you can see the sway of the loops. That's what I was going to say. This right here is what I was referring to, how far-reaching these are. And even then, they're still reaching too far out to be able to actually observe them completely, these loops. These come back to the sun. But we can't see that because it's reaching out so far that they're too cold in this angstrom. And that is what much of the upper left regions are displaying as well, only it's even harder for us to be able to observe more in detail because it has the hot surface of the sun as its background. So we won't get to see as much as we even see on this one. But in looking into which interactions actually occurred and what caused what entirely, a lot of that is easily traced by looking at where the plasma is at and where it's hottest, and tracing it down to where that initial heat began. And as you can see on angstrom 304, which is great for the singly ionized helium, which, thank you, Deep Quake, which is essentially the plasma. It's a beautiful presentation of the plasma, which shows us a lot of where that coronal mass ejection is happening. And a coronal mass ejection just means that plasma that is coming outward from the sun, outward from the corona. The corona is like it's like the sky for the Earth. The surface of the sun is, the surface of the sun. Then you have the photosphere just underneath that. That's like our, some of our crust and whatnot underneath, and the platonic plates going crazy and all that. And that's where a lot of these coronal loops and these magnetic field lines are coming from. So they're coming up out of the ground and reaching into the sky. And when they break free from the sky, that's when they become a coronal mass ejection. You'll sometimes hear about an interplanetary coronal mass ejection, an ICME. That's just a fancy term for saying a coronal mass ejection that completely cleared the sun's atmosphere. The sun has a very far-reaching gravitational pull, and it is very possible for CMEs to happen and just fall back to the sun. And that it goes out of the corona, goes into the outer atmosphere, into space, but it's pulled right back in through gravity and geomagnetic of the sun's polarities. And that's just a CME. But when you hear of a high CME, that means it has cleared the atmosphere of the sun and it will be hitting planets. Interplanetary coronal mass ejection. Now, some of these striations are actually glare right here. This is glare. You got this. So this is coming off of this. But you can actually see a coil on 171. Let me bring that back up. All right, you can see the striations from the glare, the intensity of the flare. But if you look closely, you'll see also there's a curl. It's a helix that curves this way and comes all the way to where you see this. This is interacting right here, and this is why these loops are swayed so much. They're pushed by this force. So you have the glare, which are the more bold striations, but behind it are is the actual mass, the actual plasma, and it's actually interacting with this coronal loops, which means we might see, if it cascades, yet another event. But these things are so massive in scale that they take time to reach from one distance to another. So when it's going back to where it once was, it could cause a conflict in where it connects, makes contact, or even breaks from where it's connected, which will cause another flare. And looking at this area, I can tell you that it's not ending on what we see alone. You can see loops, very, very, very far-reaching loops. There's my arrow, going all the way out over here. And I don't think it's connecting to this one here. I think it's connecting to something that we don't see yet, not quite on the Earth-facing disk, which is the part of the sun that's viewable by Earth. I believe that we are seeing that connection to another region that we have yet to see on this view. So if we take a look at, let me pull up that stereo A because it has that angle. And indeed, there is another sunspot right behind it. You'll see it in the green sun, angstrom 195 from stereo A, which is one of the two satellites that monitor from a different perspective. Well, unfortunately, stereo B is MIA. So one of the only satellites that it is the only satellite that gives us a different perspective. Everything we have is from the orientation of the Earth. Even SOHO, which is 1 million miles from Earth, and that's 92 million miles from the Sun. It's still orientated between us and the Sun. Now, what's going through my mind, and this is what I've been thinking about for a little bit now, is actually as soon as this started and as soon as I saw it was not in the regions that we were watching, is this significant to cause a sway in the coronosphere enough to impact the other region to cause that to have a cascade? It's quite likely. Yeah, it's very much like having a live wire. These coronal loops are the magnetospheres, not magnetosphere, the magnetic loops. Sorry, they magnetic field lines. They travel. Typically, when you see the calmest point of the sun, they're traveling north to south or south to north. It alternates every 11 years. And as the sun rotates, the center rotates faster than the northern and southern area because the sun is not a big solid rock. It's a plasma. So, which is basically a charged gas. So as it's rotating, it's coiling up that right, sorry, it's coiling up that magnetic field line that's going up and down until it goes around and around and around. So it's like take a rubber band and put it around an orange and hold the top and bottom in place, and then start to take that rubber band with your finger and keeping the top and bottom where they are, start spinning it, and you'll see it start to coil. That's similar to what is happening on the sun. And because of that, these very highly charged wires, they have a lot of energy. When they make contact with one another, which they don't want to do because they're all charged. So it's like trying to put two magnets that repulse each other and force them to be together. Now add electricity in that. When they touch, they react. You end up with sparks, and that's what a solar flare is. Massive spark, massive release of energy. It's a complete flash. And when that happens, you get your microwave frequencies and everything else. It does a big spectrum of frequencies. And when that happens, it snaps down to its reconfiguration of the lower end, and it releases everything above it. Now, if there's enough force in that release, it can become a CME. On top of that, if there's enough plasma that's associated over this region, where you'll see a filament over a sunspot or even a prominence that's reaching hundreds of thousands of miles into space, it could break that free too. It could destabilize it. And when that happens, you end up with a solar flare that caused a CME. And reversing it, say for instance, you have these coronal loops, but you have a filament that's crossing over them. And this filament loses its grip on the photosphere where it connects, sort of like its roots of a tree. And when that happens, it just tears itself up, causing a complete disruption of everything around it, and you end up with a solar flare, and that's a CME that causes a solar flare. I don't know if I stayed on subject there. I feel like I was wandering around a bit, but that's how my mind works. Yeah, we're still in early points of this solar flare. We're seeing these coronal loops still bend outward, and we still see some hotter points from the side loops. We see some secondary activity occurring, but the central point of the main activity is still ongoing in these photographs. This one's time stamped 0205. And I have the clock on the other side, so yeah, and it's currently 0216. So we should get a new image of this very soon. Yeah, I've got a part of the issue with not sleeping is it's hard to stay focused. I'm comfortable at least now. I don't know. I don't know. One of the things, if you see a lot of activity occurring, one of the things is that event has caused that region to neutralize to some extent. Not that it's not got the potential, but that it's not ready for releasing that potential. So imagine that if you had a good way to explain it, it's like boiling water. You're boiling the water, and the water's, you get the gas releasing upward from the heat, and as you do that, you can drop in some salt, and it gets really hot again. But then it adjusts, and it doesn't boil as much once it's found its equilibrium with that salt. So basically what's happening is it reaches that equilibrium for what's happening for the moment. Everything is kind of, gelling back together, trying to find its equilibrium again before it has another eruption, as it were. That doesn't mean that's always the case. You could just have that temperature at the right spot where the water just begins to boil and go nuts until all the water's out of the pot. I did that as a science experiment once. But in general, they take some time to rebuild up. And that's why you'll see most of these regions we've been watching, you'll see an M class once a day to once every other day, as opposed to, one after another, after another, after another. However, we do see a few that just rapid fire these solar flares to the point where there's no CMEs. It's just coronal loops interacting, going nuts. And when that happens, it's basically vacuumed out all of the plasma that it could release into the chronosphere and beyond. And it's just got magnetic field lines that are not happy, and they're intertangling, and they're getting too close to one another. And I think it was October of last year where we saw a rapid fire event like that. Well, the beauty is with this, Sydney, is that it's not something that anybody knows exactly. There was a one of the brightest minds, I can't remember his name, during the discussion of when the solar minimum had ended, and they were talking about people were panicking, saying we're going to have a global cooling phase and all this stuff. Ice age was coming. That was the latest panic talk you would see periodically. And the scientist said the problem is that none of us really know. And this was during the committee that they got together to decide if the solar minimum had ended. And he just blatantly told all of them, it's like none of us really know. And Dr. Tamithas Skov says it well, in the fact that this technology is not it's not ancient. It's very new, very, very new. And a lot of our accuracy in sunspots and whatnot, it's kind of sketchy going back before the 40s, technically before the 80s. And we didn't even fully believe in space weather as it is now with the winds in space. The solar wind particles coming from the colder parts of the sun. We didn't believe that was a thing until Dr. Eugene Parker, who just recently passed, pushed that across and continued to fight to prove it, and pushed us to the point where we now not only know about it, but we can use it to forecast many different things that not only protects our technology, but the astronauts themselves in space that we need to care about their safety and well-being. Still waiting on an updated photo from Angstrom 131. I have a video up on one of my videos. I don't know which one. I know this sounds strange. I actually watch my videos periodically because I just like to see the sun. I think it's a remarkable, beautiful thing that we can capture these images with the technology we have. But it's one of the videos that I've uploaded. There's a lot of them. And I would normally upload even more, but part of the issue with not sleeping is you would get some very badly done videos, and I'm kind of a perfectionist, so yeah. It could be possible that um, it could be possible. My pup distracted me. It could be possible that the SDO satellite is being repositioned due to the R situation. The high amount of frequency being sent out could be causing disruption to the satellites. So we may not have all of the imagery for this. That happens periodically if it's intense enough that it impacts the satellites. And two back-to-back warnings with the flares, I probably caught them off guard to some extent. So we'll see. Then again, there's probably a person that does these satellites going, can't catch us off guard. This is interesting. I think I see plasma movement, maybe in association with this. This looks like actual in motion plasma moving quickly, which would mean that this event, CME, because there's definitely a CME associated, so I can tell that already, may include Earth in its projection. But I see striations here, cooler points of plasma that are not matching the rest of it, which means overlaying. And it's definitely got a blur effect, which means high motion speed. And it seems to be coming from the region of the solar flare. So I am expecting this possibly to be an ICME that can impact with Earth. That's just based on this image right here. We'll need to see more to be sure. It could just be a transition from solar plasma from one region to another, but it looks like very high range of motion compared to the background and other areas. No worry, Ken. It's You be whoever you want. That's the beauty of the internet. Anonymity. I didn't intend on actually making this channel my name. Originally, I created this channel because the person that was my mother was watching earthquake stuff. She was watching, live earthquake monitors and things of that nature, and my sister as well. They're really into this stuff. And I wasn't at the time. I was still going through, stuff, things and whatnot. But yeah, it was a bit of a fiasco. They were watching somebody who was morally corrupt in many ways, and they were trying to profiteer off other people's hardship, and not to mention some disturbing qualities. Anyhow, so I created a variation that was supposed to be temporary for my mother and sister until we found something better. And it started with just the monitoring in 2018 of Hawaii. Yeah. So one thing led to another, and that it wasn't him actually. It wasn't him. He does profiteer off of fear, and he's a bit of a fearmonger, and I don't understand a lot of his science because it is very incorrect. It's very scatterbrained, and the math doesn't add up, and his self accolades are completely false. However, the sad part is he's not always wrong either. He's actually got some good points, or has some good points. I hate the word God. He actually has some good points. And it's bizarre because, you have this person with some good information, and he handles it well to some extent. And he's got a decent mind for it. But then he just goes left field with everything else and just ruins it all, in my opinion. To believe it or not, I followed Dutch Sense, not knowing any better when I first started. And I was like, this guy's good. I didn't know any of this stuff. But then I started to study and learn about earthquakes and how they happen and the science behind it, and started to see that this guy, he didn't know. He didn't know the very basic functions of what an earthquake is. And he would just make outlandish claims that seemed to get a lot of views. And he monetized like crazy, and started to declare war on agencies that it's so bizarre. Let's put it this way. If those agencies wanted to shut him down, he would have been shut down. He's just doing that for attention. It's just so bizarre. But yeah, so I mean, he has some good stuff, but you have to take what he says with a grain of salt, and you have to verify it with other people. He's one of those people that, sadly, because of how much misinformation he puts out, you need to verify it. He's not factual 100% of the time, and even I make mistakes, but on purpose. I think that's a bit of a moral question, and I know he does that on purpose at times because of his emotions involved in it, and possibly interest in making money on it. Now, the person that I was referring to, I actually got him kicked off multiple funding sites, forced him to pay all of his funds back, proving that he was scamming people, and got him shut off of YouTube for about 6 months or something like that. Hey, he's back now. He's got his regular religious-like following, and claims that he's saving the world by showing people spectrums. But it's so bizarre. Yeah, like this right here. Yeah, looking at my Hawaii chart, and when I first started this, it was just like, if you look at the left side, that little left corner, that's basically the entire page. That was the entire page, and that's all I had. Nothing else. But yeah, so that right there was all I showed, and it was actually more accurate than what he would have, because when an event happened, he would panic because he didn't have an answer. When people would ask questions, he would take it down. The guy I'm talking about. I don't want to state names. I mean, the guy's he's who he is, whatever. But I provided my mother and a sister an alternative. Helen came with me as well, which is awesome. She's been here since day one, and I believe J Dog as well. But yeah, so basically, and that's why I'm nonprofit. I don't do monetization. I've had YouTube up and down sending me messages telling me I'm welcome to the partner program. You've lost your permissions to the partner program because you didn't use it. Welcome to the partner program. Back and forth, because I refuse to advertise. I refuse to put advertisements on my channel. This is free information from the agencies. We pay for it with our tax dollars. And due to the freedom of our country, we get to see this stuff. So it's free. Why should I charge to show you what you've already paid for? Here we go. We got an update. So, region. Okay, so we got some. Okay. Yeah, there's some motion, but that may be coming back down to the sun. So that may not be an ICME. Yeah, it looks like it's going this way. I wonder if there's a polarity over there. Let's see. All right, looking at the HMIBC. That'll show me as soon as it loads. All right, yeah, there is. Okay, so I think it's being pulled back down. I don't think that's an ICME, the part that's coming towards this way. So it's quite possible that this may not impact Earth at all, which is good, I guess. I like seeing the auroras, but yeah. My mother is currently watching my niece's newest baby, and helping my niece and her husband with their two boys. So she's not necessarily MIA as much as just preoccupado. Yeah, we are seeing some secondary events from this, but they're all smaller, registering lower than the upper line we see already from the frequency. And it looks like there's already some motion heading back with the loops. Now there's going to be a cool cloud movement from this one, I imagine. I want to see how far that goes, but that's going to be angstrom 193 and 211 to be able to see the chronosphere. All right, here we go. So looking at angstrom 191, yeah, you can still see a lot of bending and swaying. This does appear to be very southward, which is nice. But I can't see too much of an impact outside of that area, as it were. Yeah, it's going to take further images to be able to loop and pictures one back to back to back to be able to see exactly how this transitions for the sun and what else it impacts. I think Helena is working with her garden. I've been sort of out of the loop the past few days dealing with, ooh, and I love this part, dealing with trying to get myself back into some frame of mind where I can think straight. I'm getting there. But yeah, so this right here, this is where I am seeing the potential, because I mean, not to mention the that region's going off the Earth-facing disk, part of the sun that's viewable by Earth. But we have sunspots that are not even viewable yet. They're already interacting with what is, and that is a massive line of activity. And this is not unheard of. We've had this before. The difference is that this activity is a little bit sooner than some scientists have expected. So some are speculating if this is going to be a shorter cycle, or is it just going to be a more intense cycle? I think that's basically all my thoughts right now on this. I mean, like I said, I've been sort of out of the loop. I would normally like to look at these images far more, but I get these migraines from looking at these too long when I don't sleep, and kind of shuts me down for even more for a while. Yeah, it's completely my fault because I look at every pixel, every detail. I zoom this in to the point where I'm looking at the shading of the pixel next to it and how much that changes. Yeah, the world needs people like that to some extent. It's because if nobody questioned things, then there would be a huge miss in advancement of humanity. He questions things. That's good. I think he takes advantage of it, and that's bad. But he does question things, and he's right about a lot of things. I'm very convinced. I cannot prove it yet, but I do see some correlation in some of the research I have. I've got pages I've been working on. And it's about 50, 60 pages of random data that shows there is a correlation, possibly, between the earthquakes and solar activity. But it's not in the way most people assume. It's not immediate. It takes time for transition of that energy from impact of the plasma from the sun through space onto Earth, sunk into Earth, energized, heating up deeper into Earth with its energy, and then causing an acceleration in the already occurring process of the earthquakes. So I think that from the research I'm doing, I believe it shows that solar activity does, in fact, cause earthquakes, but it does it in a way that it was already going to happen, but it makes it happen sooner. It accelerates the process. And that's what I'm seeing. And that's because we have a very magnetically charged planet, thus our magnetosphere. And when this energy, this plasma, which is also charged, interacts with our magnetosphere, it puts strain and motion into the polarity of the Earth. Because our polarity of the Earth isn't as simple as a dipole. It's not north and south. It's very much it's very much like the sun in a way. It has a lot of positives and negatives, and that's why it is so complicated for NOAA to put out a report on the current shifting of the magnetic poles that's occurring. And it has always occurred. That's not anything new. It's a thing that's happened just like the sun happens every 11 years. Ours is just a longer striation of phase there. But yeah, but you're going to see a lot. Wages went live. I kind of like that. Wages World, that is. I like that guy. He gets a little sketchy with some of his information, but he does really well. He's a very intelligent guy. I like that guy. But anyways, yeah. So the what was I saying? I totally got sidetracked. Oh yeah, the magnetic poles. So as it's transitioning, and a lot of people are trying to show that our scientists don't know what they're talking about and these transitions are happening faster, they're using the very data that the scientists put out. And they're using data that's actually old. It's hilarious because they're using NOAA's report that is like, I don't even remember what was put out right now. But anyways, it was put out years ago. It's not new. And they don't have a new one yet. They're trying to work on a new program to make it more dynamic so we actually know shifting and whatnot. But it's very complex because our polarity on the Earth is not something simple to measure north and south. And thus, I believe the strain on the magnetosphere makes more of an impact to the Earth and causes these events to accelerate due to that very reason. Well, I think it would have done it either way, but more so because of this. Exactly. Very well stated there, Ken. Like I said, I don't dislike Dutch, but I don't like misinformation. It's one of my things. As a analyst, a professional analyst, one of the things I would fight for is complete 100% truth. The problem is there's a gray area, and that's the information we don't really know. And when we have something we don't know, we can't say if it's true or false. We can speculate, but that's not fact yet. And I think Dutch, as brilliant as he is, a lot of times he goes a bit off the deep end. That's the best way I can say it. The eye. Oh, that is from my research I've been doing. I think Dr. Tamitha agreed in something I read of hers, but mostly from one of her colleagues. I read their report. Someone that worked with her in another project. Uh, it's due to the shifting of polarity on Earth, and a lot of people think that because the shifting, there's weakening spots and collapsing, but that's technically not what's happening. I like Tamitha's explanation. Dr. Tamitha said, if you take she explained giving her kid a bath. If you take a bubble bath and you put all the toys for your kid in there, I explained it as dishes, uh, and you have the couple of toys that float. And that's the polarity you're all seeing. We see that very clearly. But as the shifting occurs, it's not as strong in certain areas. But that polarity is still strong. It still has the magnetosphere is still going to be there, and but it's going to start changing shape, and it's going to start changing how it transitions all that radiation and plasma from the sun into the tadpole tail and release. It's going to change it slightly. You're going to start seeing some slight changes to how the magnetosphere operates, but it will still operate. And as that you drain the water from the tub, because these poles are shifting to where they're not as strong as they were anymore at that location, you start to see other toys start popping up. And those are other polarity points. So even if the north and south dipole were to be completely gone, it'd be a little more vulnerable, because that's not actually what's happening, but it would be a little more vulnerable. But overall, we would not be like Mars or Venus getting bombarded heavily by this radiation and plasma just scarring the surface. Instead, we would have, it looks like we got another peak. Big one, too. It's definitely going to be an M class, it looks like. Anyways, yeah, so it's the Earth's energy in the core is fantastic in essence. We have a liquid core. It's I think they call it a mixture, but it's a liquid core that allows this transition to occur, and that's a good thing because of that we can propel the plasma from reaching the surface of Earth. I kind of rambled on there, but hopefully that made sense. Are you asking, does the sun heat the core of the Earth? This may not make it that high. Looks like it already peaked. Looked stronger on the shortwave. If you're asking if the sun, and that's almost directly from a NASA report I read the other day. Well, actually, yeah, it's a slightly molten outer and inner core. It's not exactly liquid, but it's not solid. It's in the in between stage. And that is also correct. The Van Allen belts do transfer energy, and to the core of the Earth is questionable. A lot of I believe it does, based on what a couple of the reports I've read were, but there are some scientists that disagree with that and state that that energy is trapped up there and does not make it completely to the Earth, which also makes sense based upon how our auroras and whatnot function. But I believe that that heat trapped there transitions and causes trying to think of the best way to state it. The frequencies that do not penetrate our atmosphere due to the Van Allen belt, they're redirected back down to the Earth. And there are natural forming frequencies that occurred before we did anything. Thus, the Van Allen belts were, there. And I believe that that is essentially the process of maintaining the Earth's temperatures and all that jazz. So far, no, there's no sign that the core is actually heating, as in accelerating heating, but there are signs, according to some science, that it is cooling. and it's a constant process of cooling. And that eventually our core, the Earth's core, will be, Mars is the model of what the Earth will be eventually in the future, is what they state, with a solid core. And that is what's expected through the research of science currently. However, heat does transfer, and as things balance out, and that's what everything's looking for. All matter is looking for equilibrium. And as matter does that, heat transitions to where it's cooler. And that heat in the core, where it's really, just blazing hot, it would transition outward naturally. And I think that's where a lot of that confusion of some of the pseudoscience and conspiracy, well, I hate to say the word conspiracy because it's not always conspiracy. Better way to say it is half-truths. the half-truths. They're there, but they sometimes got some of the facts wrong. I have not read that anywhere. That's new to me. If they believe the Earth's core should be solid by now, I think that somebody's looking at a short-term scale instead of long-term. They forgot to carry the zero. Now that again goes to we don't really know. All of the carbon dating has basically caused a lot of speculation and a lot of misdirection. And a lot of that information is based on carbon dating, which has been, once again, not completely accurate. It's a cool tool, and quite possibly it does prove a lot of things based on half-life procedure of certain, atoms and molecules and whatnot. But in all, it's not a constant. And when you look at things in a transition of periods and situations, half-life doesn't always react in the same amount of time. So you end up with half-lives that sometimes are longer and shorter, depending on what the element and location and environment of that location around it even, which, it's just there's a whole lot more than just saying, well, this is at this process of decay, therefore it's this old. And that's how they're trying to age the Earth. So it makes it not a solid fact. Oh yeah, there's a lot more accurate ways to do it, but not everything always has those elements to which measure that. So you end up with a lot of things that you try to measure something, but you can't find a consistent number. And this is where statistics comes in. And the problem with statistics is it is the art of measuring something enough times to get the answer you want. So I don't trust statistics because statistics will fit the narrative of whoever wants the answer to be what. And it's usually whoever's funding the project. And that is why I always revert back down to raw data. And the raw data shows that it's too inconsistent to be considered legit, in my opinion. Given more time, we might find a better way to do it. But as of right now, there's too many outliers that mess up this entire method, as well as some others that they've tried. And if you look at some of the interesting data, if you look at the raw data they've used, the date of the Earth in some stages it's younger than how long we've been on Earth that we know of, for fact. So it's like the Earth is only 500 years old or something. I can't remember exactly how old the data came back with. And I'm just like, oh, okay. That was a good spike for just to see. When I used to do analytical work professionally, I would have to track down terrorist groups and things of that nature. And I would get all kinds of information. I would get information from human sources, from technological sources, and even indirect sources. We would find tracking patterns. I mean, there would be so many different ways you do this. And the complication thereof in doing this is that not all the sources are 100% reliable. Some of them worse than others. And then even those that are very reliable get it wrong sometimes. And that's why it is very important to be able to collaborate any data. And if you cannot collaborate data, then the data cannot be considered accurate. And that's how I did my job. And in doing so, I've never failed a mission. Well, my team has never failed a mission, I should say. I was never an independent band. I was never an island. And I always had a wonderful team. But yeah, by looking at the data correctly, by collaborating it and ensuring that the data was correct before making action, then you can make a decisive move. And unless you do that, and if you're just looking at, well, this averages out to be this, despite the fact that they're completely askew from each other, then your information is worthless. It's not accurate enough. And I would have thrown it out as failed project. We're currently seeing secondary events occurring at the region of that solar flare. That's what these smaller ones are. These basically, when I was explaining when that event happened and the loops were swayed, pushed away from that solar flare explosion, as it were, that giant energy release. When that happened, it swayed all those loops outward, and they're slowly working their way back. And as that happens, some of them collide, some of them just lose their grip in the photosphere and sway. Some of them just get too close in self to another opposite charge and reconnects, causes a reconfiguration. And any of those scenarios will cause another solar flare, and that's what we're seeing. As the region starts to stabilize, the coronal loops that were swayed from this event starting to find its way back to its most stable point. In doing so, it's sometimes causing a disruption. Quite beautiful. Yeah, so you definitely understand from your, I'm sure, conversations with your son. Now, as you see also, this is why I'm not as exciting and as popular as many others. Because I don't do this for popularity. I don't see myself as some person that needs to be in limelight. I'd rather not be. I just believe in truth, and then that's not always very exciting. This is a very interesting little layout here. So we see coronal loops. Where's my little arrow? Hey, there you are. All right, so we see coronal loops going like this. And then we see some coronal loops going like this. There is a chance. This is the kind of things I look for, and this is not going to be like a severe flare or anything like that, but it's something fun to watch. And there's a chance that these can cause a disruption if these loops decide that they need to be more stable in an upward position over here. And when that happens, it's going to get closer to these loops that are doing this and could very well cause a solar flare. And these are the crossing points I look for when there's not much going on in the sun, to see where the potential is, as it were. Data collection, yeah. I worked a lot with them. I can't talk much about that, though. That's one of the areas. I could talk about some of the missions I've been on, and I could talk about the success of the missions of my team, but I can't talk about a lot of the details, as it were, which are the data collectors and the exact sources. That is a beautiful display, though. Let's take a look at the coronal holes. I have not viewed the depth and size of these lately. Oh, that is something. There's a lot of solar wind particles that are going to be coming out of some of these areas. Not to mention, this entire center area is shallow, but still, it's going to provide some of that wind. And you got the southern region having a growing, looks like, could be just overlapping parts of the corona atmosphere, plasma. But it looks like it may also be expanding slightly, reaching up slightly. Yeah, nothing too severe, though. Still really cool looking. Thank you, Ken. I am just a man doing what I do. Yeah, when this updates a little more, we can actually see that shockwave and how far-reaching it is. So we'll see how that M class, M-7.32, 7.34, we'll see how far that reached with its force. These videos that you see update slower than the raw images, of course, But you're going to see that in about maybe an hour, you'll have the data to be able to look at this and see exactly where the corona of the sun was impacted by that solar flare. That is the essence of science. We constantly learn that we do not know. And the best we have is to continue to learn and improve. And as long as we remember our humanity and don't revert to more barbaric natures, we will continue to improve. There, hopefully that improved the image some. I upped the amount of data. Knocked over my cup. Fortunately, it was empty. Now, this is not as nice as when I do the 4K resolution, 8K resolution images, but this is I think 1080 resolution, and then I just process it and do some adjustments to try to make it clearer. Quick look at Hawaii. I like the clouds in these images. They're always so, yeah, just fantastic. Quick check of Yellowstone. Appears their camera is offline. And back to the sun. That was a beautiful view of the CME that happened there yesterday. This little area right here. You'll see it again once it resets. Ah, it's fantastic. I'm just starting to see the beginning images of the M class. Give it about another hour, and 6 more images, and we'll see a greater detail of how much is impacted. If it's very vast, we'll probably need more images. Viewing this on the 304 angstrom so we can see the plasma a little more clearly. This is a good one. This is a good pardon me. This is a good example of a CME that causes a solar flare, followed by another CME.